Hey everyone, how's it going? Hope you're doing well. Welcome back to another episode of Blockchain and Beyond. And as always, I'm your host, Farzan. On today's episode, we'll be discussing Bitcoin. I'll go over the background of the project, what we know about the people or persons behind it, how it functions, and how it's changed our understanding of blockchain technology since its inception. And then, as always, I'll round up with my own opinion of the overall project. So, starting off, Bitcoin is a cryptocurrency which operates on the Bitcoin blockchain and it has been operating since 2009, making it one of the oldest and most widely accepted cryptocurrencies in the world. It is also arguably one of the most influential in successfully implementing blockchain technology into a purely decentralized medium. Bitcoin also uses a proof of work system and has a fixed supply of 21 million Bitcoin, where supply is introduced in a sequential manner over a large period of time. And if neither of what I just said makes sense, don't worry, I'll cover it on a bit further in this episode. So the person behind Bitcoin goes by a pseudo-anonymous identity known as Satoshi Nakamoto. As far as we know, he was the original inventor of Bitcoin, and he used this identity to discuss Bitcoin with others on online forums. He eventually published a paper titled Bitcoin, a peer-to-peer electronic cash system, which delves into the key concepts behind Bitcoin, such as how coins are moved, how blocks of data are timestamped, how transactions are broadcast, the incentives for the people participating in the network, and also how proof of work functions. And although the paper is only 9 pages long, a lot of the text is more about the context in which Bitcoin was created and why it was created. It makes a lot of references to our current financial systems, especially surrounding the 2008 financial crisis, which is something that I think everyone should read and get a good understanding of. But the paper also goes in depth regarding the mathematics behind Bitcoin, and how the network, adjusts itself as the network expands, which isn't going to be everyone's cup of tea, so it's not something that everyone needs to particularly know. So the next part is discussing how proof of work actually works, because it is the fundamental underlying algorithms in Bitcoin. So for the sake of simplicity, I'm going to use two terms, or I'm going to combine the use of two terms. These are nodes and miners, and I'll explain what they are, but while I'm explaining it, they basically mean the same thing. So firstly, a transaction is broadcast to the network. This transaction could be me sending Bitcoin to my friend, and this message would contain the data of how much I want to send, how much I'm paying in transaction fees, who I'm sending it to, and it will also contain certain information to verify that I was indeed the one who signed this contract or signed this message, and which other people can then verify and validate. And this is done using a public and private key pair, which goes a lot into cryptography, but it's what enables me to sign a message, and it prevents other people from mimicking my identity. So this transaction that I broadcast is sent to nodes within the network. So the nodes take hold of this message, but then they also propagate it further to other nodes within the network. So each node will collect a number of transactions into a block. A block, as mentioned in some of my other episodes, is a set of data which has a maximum size or capacity. And as the size of the block is the restriction, nodes will generally prioritize transactions which have a higher payout. So transactions which are paying large amount of fees are ones that will be prioritized by these nodes, which makes sense, as these nodes will want to maximize their profit, maximize how much Bitcoin they're making. And now this is where the proof of work part actually begins. So for the block of data that they have created and gathered, they will begin to find the proof of work. So they will carry out a calculation involving the set of transactions, a answer from the previous block, and also an unknown number. And they will carry out a mathematical function known as a hashing algorithm to look for a particular result. So what this looks like in practice is a node will take a set of transactions, and the number 1, for example, and then apply the hashing function to it. And they are looking for a specific answer. If they do not find the answer, they would then apply the number 2 to it, and so on and so forth. And this repeats until the node finds an answer which meets its requirements. And the type of number it's looking for is a number which begins with a certain number of zeros. So for example, if the requirement is that the answer begins with 10 zeros in a row, if it's able to find something which matches this criteria, it can let everyone else know that, hey, I found the answer. And once it's found the answer, it will broadcast this to the other nodes, who can verify that the answer that they've given is correct. Each node will then take this block of data and append it or add it to its own version of the blockchain which it currently holds. It will then broadcast this to the other nodes in the network. The benefit for the node who actually found this, who confirmed this block, is that not only will they receive the transaction fees of the transactions that they had verified, but they will also receive a block reward, which is something that we'll discuss very shortly. The other thing that we can discuss now is the difficulty of Bitcoin's proof of work algorithm. So I mentioned that a node is looking for an answer which may begin with 10 number zeros in a row, followed by any string of values. This is how the difficulty of the network is adjusted. So as more and more people use the network has a higher capacity, or is measured in hashing power. So as more people join, the network will have an overall higher hashing power. This represents how many calculations can be done in a second. And as part of Bitcoin's code, it will automatically adjust this to represent the increased capacity of the network. So for example, the difficulty may be modified from 10 to 15. And in this case, it means that the answer that the network is looking for is an answer which begins with the number 0 15 times, followed by any string of values. And the opposite is also true. If the network's capacity drops for whatever reason, the difficulty modifier is reduced, making it easier to validate transactions. The idea is that on average, a new block is added to the blockchain every 10 minutes. Now, speaking of block rewards, this feeds directly into Bitcoin's tokenomics model. Bitcoin has a fixed supply of 21 million Bitcoin, which is verifiable in its code. And the minting of new Bitcoin is done algorithmically, meaning that it follows a certain pattern. It is a product of a new block being added to the blockchain, and this is known as the block reward. At Bitcoin's inception in 2009, the block reward was set to 50 Bitcoin. Whoever successfully proposed a new block would receive 50 Bitcoin from the algorithm. Now, approximately every 4 years, there is an event known as the halving, which is also coded into Bitcoin's algorithm. When the halving occurs, the block reward is reduced by half. In 2012, the block reward dropped to 25 Bitcoin from 50 Bitcoin, and in 2016, it dropped from 25 Bitcoin to 12.5 Bitcoin. Most recently, in 2020, it dropped from 12.5 Bitcoin to 6.25 Bitcoin. And this process will occur every 4 years until the year 2140, where the block reward will drop to 0. Although it seems a long way away, to put it into perspective, as of now, which is December 2021, approximately 90% of all Bitcoin has already been mined and is in circulation. This doesn't mean that Bitcoin will become obsolete in the year 2140. The block reward was just a temporary incentive for people to participate in the network and to reward those who participated genuinely. Once the block rewards hit 0, nodes will then rely on transaction fees as their incentive to operate. And with that, it covers mostly everything I wanted to discuss. So my overall opinion on Bitcoin is that it has a large advantage being one of the first cryptocurrencies not only to be created but to be widely accepted and to hold significant value, whilst also being built on a robust system which, solves quite a lot of problems such as cyber or imitation attacks. It properly rewards genuine actors and offers strong security and decentralization. Bitcoin also has a number of layer 2 solutions being developed. These expand on Bitcoin's functionality whilst still relying on the base network for its security and integrity. One of these is the Lightning Network, which enables users to send Bitcoin in real time with almost non-existent fees. And then we also have identity solutions such as Microsoft Ion, which also uses Bitcoin's network to secure the work that it's doing. And all of these projects, require their own episode to really delve into. And yeah, that's really all from me for today. It's been a pleasure discussing one of the first major crypto projects, and I encourage everyone to read Bitcoin's white paper, if not to understand the technology, but to understand the context under which Bitcoin was created and the problems that it aims to solve. And even maybe just a little bit of how it works underneath the surface. As always, if you have any questions or comments, feel free to reach out to me on social media, and it will be good to hear from you. But until next time, goodbye.